Okay, so I just wanted to go through these questions on this con real fast to make sure that you actually understood what they were. I didn't want to tell you all the answers. I wanted you to think a little bit for yourself and see if you could kind of put some things together. Which parabolas open up? Well, this one definitely opens down. That's easy. This is an up, but make sure you read where it says choose all that apply. There are actually three of them. This one also opens up. Okay, so far so good. Draw the parabola's axis of symmetry. I did this one yesterday. The axis of symmetry is that vertical line that goes right through the center of the parabola and creates the reflection in the middle. So I'm actually going to put that point right on the vertex and then swing this guy down. And now that green line perfectly splits that parabola in half. That is the axis of symmetry. In this case, the axis of symmetry is on -3. Well, just moving, thinking ahead, if I look at this axis of symmetry, x equals -3, that's halfway between every point on the left and the right because they're reflected. So like this point right here is 1 away, and then it's 1 away on this side also. Specifically these x-intercept points, this one and this one. This one's -1, this one's -5, because the middle of them is -3. They're both 2 away on each side, because the reflection is an equal distance on both sides of the axis of symmetry. It's going to come into play in a few questions. Mark the vertex. The vertex is just a single point, and that single point is either the maximum or the minimum. It's on the symmetry axis, and it's either the bottom or the top. In this case, the bottom, the minimum. It's a point right there. And that vertex point would be 2, comma, -4 as a coordinate. We're going to talk about that next. Once again, pictures, you can do this with your eyes. Exactly one x-intercept. Make sure you read if it says x or y, because that's a really important point. All of these parabolas will have exactly one y-intercept, but this one has to have exactly one x-intercept. Cross the x-axis just one time. Well, here's my x-axis. This blue line crosses the x-axis 2 times. No good. Here's my x-axis here. This crosses the x-axis never. The parabola never gets to the axis. It comes down, reaches the minimum above the axis, and goes back up. So this has no x-intercepts. Here's the one where it comes down, it bottoms out, has a minimum right on the axis. That means that the vertex point is on the axis. There's only one time this graph touches the axis or crosses the x-axis, and that's right at the vertex point. Okay? This is where it gets a little fun. I think I did this one in the video before. Vertex is at 3, 5, and the y-intercept is at 1. Well, I have 2 points that I can move around to manipulate this parabola. One of them is the vertex point, this one. And one of them is just a random point on the side of the parabola. So I'm going to take my vertex point and put it where they tell me. They tell me to put the vertex at 3, 5. So I'm going to put this vertex at 3, 5. And they tell me that the y-intercept has to be 1. So this point has to be on the y-axis at 1. And there it is. I have a vertex at 3, 5. I have a y-intercept at 1, and I'm good. Here's where it got fun. X-intercepts are -3 and +5. So it's going to cross the x-axis twice at these two values. And the minimum value is -4. So the minimum value is where my vertex is. So I'm going to take that vertex, I'm going to drag it down to -4. So now my parabola bottoms out at -4. And I have to cross the x-axis at 5 and -3. All right, so I'll take that point and I'll put it on the x-axis at 5. But there's no other point over here to drag over to -3. I can't do that. This is at -5. I need this to be at -3. That means that my parabola is going to have to shift a little bit. Well, if I take this and move it, well, now it's at -3 here, but this is a +3. So that doesn't help me. moving this x-intercept has to stay where it is. But now if I take my vertex, my minimum value, they don't tell me it has to be on the y-axis. It's just the minimum value is -4 on the y. But watch this. Isn't the minimum there still -4? And the minimum there still -4? And the minimum there still -4? It still bottoms out -4 and turns back up. But now I changed my y, or my x-intercept over here. Now my x-intercept's gonna be way out here at like negative, I don't know, 11 or something like that. So by moving this left and right, this vertex, I'm changing my other x-intercept. Look, now my x-intercepts are 5 and -7. I gotta get to -3. So I'm gonna keep on going to the right and check that out. Now I have an x-intercept at 5 and an x-intercept at -3. I meet both my requirements there, and my minimum value is still -4. Very good. And take a look at this. So my axis of symmetry, my center line on my parabola, is at x equals 1. Well, x equals 1 is exactly halfway between the two x-intercepts. From 1 to 5 is 4, and from -3 to 1 is 4. Or you could say that 5 and -3 are 8 apart, and therefore the center of those would be 4 away from either side. So it's either -3 plus 4 or 5 minus 4. So my x value of my symmetry line is 1, the center of my two x-intercepts. That'll be true every time because the parabola has to have reflective symmetry left and right based on this axis of symmetry. And that's what you need to know to answer this question. They don't give you a picture. They just give you the information. Parabola intersects the x-axis at 3 and 9. It's crossing x at 3 and 9, and they want the x value for the vertex. Well, the vertex is on that symmetry axis of symmetry, so it's got to be the center of the parabola. Well, the center of 3 and 9, that's 6. You don't know the y value. You don't know what the minimum or maximum is. You don't even know if it opens upward or downward, but you know that halfway between the x-intercepts is going to be that vertex. And that vertex is my symmetry line, and that's where I'm going to have my x coordinate in the middle of 3 and 9, 6. It'll be 6 comma something for y. There's not enough information to get that from this, but you know it's in the center. And that's how that should have gone. All right? That was fun.